Hi, welcome to this video. Today I want to talk again about the CH chip I showed in an earlier video, where I created this demo example of the USB host to serial converter and showed it via an ESP32 and a display. While developing the firmware for the chip, it was always needed to use the proprietary software from the company VCH, who is building and selling these chips. So I sat down to create a small Python script to flash them via a command line command, and also to just flash them while compiling the firmware for it. You may saw an earlier video from me where I showed an Android app to flash these chips. I took a little bit of this code and put it into the Python environment and used it there to flash all the CH55 chips series. There are the different ones in this family. And this video may be not so interesting for you if you don't want to use these chips, because it's just meant for these CH chips, and it could be interesting for you if you want to do something with USB in Python. So if you are interested in this, you can also watch it. Using the CH flasher is quite simple, and with this video I want to make a short manual how to get it running and what you need to do to get it working. So first of all, I will put the link to my repo in the description, where you can simply download it, and just an overview of the script here. I will go into much detail of the flashing script. It's quite self-explanation because the functions are quite understandable. So if we go to the bottom, these are the real functions, the function calls. It will first just look if a bin file was successfully placed in the command line. After that, it will detect which version the chip has, or which bootloader the chip has. So because the bootloader 1 is very different to the bootloader 2, and that will get then either all use version 1 voids or version 2 voids. So the different functions here. Okay, but the main manual is in the README file. So if you want to use the Python script itself, you need to install, of course, Python 2.7, and also you need PyUSB, which is used to communicate with the USB devices. So you need to run pip install PyUSB, or on Linux you also need to install the Python pip plugin. So on Windows you also need the Zadig tool, which I linked in the repo, and you need to download it. And it's a quite simple tool, but it is needed because Windows is quite restricting the access to USB devices. So you may know it from the past, where you have to go into some compatibility modus in Windows to install some unsigned drivers. And today the Zadig tool makes this simple for you to use it. After you open the Zadig tool, you need to select options and list all devices, because otherwise this list will only show the devices that have no driver installed, and normally the CH chip will get installed automatically, but you still need to change it to the right one. So there should be one line which is called USB module, which is the CH chip that is plugged in right now, and you also need to plug it in, and it needs to be in the bootloader mode to be recognized. And after you clicked on it, you can just check if the USB ID is correct. And original, there is a CH55 driver installed, but we need to select the lib USB Win32, and then we need to click on replace driver to make the Python script compatible to it. This will take 1 or 2 minutes, and in this case it wasn't very long. And you can also see now that the driver was successfully installed. In the device manager, you also can check if the driver is correctly installed. If it is shown like this, then it's all correct. And we can go to the Python script and flash a new firmware onto the chip. After you downloaded the zip file from the repo, you can extract it anywhere you want. And you should have these files in there. The exe is a compiled version of the flasher. That way you don't need to install Python or the PyUSB core. And speaking of PyUSB core, we can open a terminal by pressing start and then command. And to install it, we have to enter pip install and PyUSB. This will download the PyUSB and install it into Python. So now to flash a CH chip, which is in my case connected to the USB, I will just cd into the folder I'm using. And there was another folder. And now we should see the files. And to actually flash it, we need to enter Python chflasher.py. And after that, we need to enter the file we want to flash. So in my case, it's just blink.bin. And if we would use the exe, we could just remove the Python and replace the py by exe, and then it would work the same. So if I now press enter, there should be something, and it successfully found it. CH55x chip. It has the bootloader 2.31, which is a newer bootloader. This script also supports a bootloader 1.1, but that one isn't shipped anymore, so you would likely get the newer version, so this one. Then it will erase the flash, because if it's not erased, the bootloader will not allow a new writing. Here it will then load the firmware file, which in this case it's just 900 bytes big. It will write the firmware, and after that it will verify if it's correct and will exit it. And that's already it. If I now try to flash it, it should not work, because after the flashing the chip gets out of bootloader mode. So now it's not accessible anymore. The main reason why I added this script is because in this USB host example I made together with Bitlunis, it was always necessary to open the VCH software and flash it via that software. Now I have in this repo the exe version of the CH flasher, and inside the compile.bat I am also simply flashing the created project to the chip if it is connected. Otherwise it will just print out the error. And that way the compiling is really just a one-click solution. So you click on compile and it will directly flash it.
Okay, that's all I want to say for the CH flasher. If you have any questions, please ask them down below, or if you like this video, please give a thumbs up, because that helps the channel. And wish you a great day.